This is about a bundle conductor three-phase transmission line. This one is a bundle conductor three-phase transmission line. So you see the three phases: A, phase B, the middle, and phase C. This is a horizontal configuration, three-phase bundle conductor line with horizontal configuration, meaning the conductors are arranged in horizontal configuration. Can be vertical as well, like way here, E in the middle bottom, and then C there down the bottom. So it can be vertical, it can be horizontal. This is an example of horizontal arrangement. So for this, we have to find out the inductance per phase and the capacitance to neutral, as we have been finding out. The diameter of each conductor is given as 25 millimeter, and also the spacing between the subconductors A1 and A2 is given, which is 0.25 meter. Is the same between the other phases subconductors. B1 and B2 should be 0.25, C1 and C2 should be also 0.25. And then the distances between the phase conductors between A and B is 7 meter, B and C is also 7 meter, but between C and A it will be different from here to there. So it will be 7 plus 7, which is 14 meters. So this one is an easy one actually. So what we have to do, we can calculate the mutual GMD first. DM, which is mutual GMD, is easy. So what we do, DAB, DCA. So DAB times the DC, meaning the distance between B and C, times distance between C and A, and we have 3 terms in it, so we'll take the corresponding root, which is 1/3. If we put those values here, DAV is 7, DBC is also 7, DCA is 14. We put those, and then we take cube root. What is the final answer from let me know? Not more than 1 minute. 8.82, that's the correct answer. That's must confirm. I need 3 more people to confirm that they are getting the same answer. 8.82. I need 3 more of you. Umeshan got it. Thank you very much. Dunge. How do you say this name? Dunge, how is your name? It's very difficult for me, but I want to learn. How do you say your name? You don't have microphone, eh? I couldn't hear. You got that answer as well. Thank you. We got no microphone. Okay, but there is a microphone by default in the laptop. I don't have any microphone, external microphone actually. I never had it. I'm using the one that is there by default, all the microphone and speaker. Thank you very much. So we got that DM now. Now after that, what we have to do? We have to do the self mutual distances. So self mutual distance, you can consider any of them. So when we are considering self mutual distance, meaning DSL, L is for inductance, and DS is for self. So for that one, you can consider either only A1, A2, or B1, B2, or C1, C2. They are the same. There will be no difference. We can consider all of them and do a very long calculation. The answer will be the same. So let's consider phase A, and we have 2 conductors. We will have to consider all the distances between these 2 subconductors. So if we start with the first, which is A1. So what will happen? The A1 is on distance, self conductor A1. Done. When we're done, we go to the next conductor, which is A2. So A1, A2. So we're done with conductor A1. Can you see that? We're done with conductor A1 or self-mutual distance calculation. Can you see that we're done with conductor A1? We can consider the conductor A1 its own distance, which is the A1. Then from A1 to A2, there is no other conductor involved. We're done with A1 conductor or subconductor specifically. Is that clear? Let me know if you understood this. We're doing the same thing, but I want to verify once again we are getting it. So the next one is the conductor A2. So it will be A2, A2. The self distance of the conductor A2. A2, A2, and then from A2 to A1. We got all the distances involved in the process of calculating ds for inductance. So power, now it will come. There are 4 terms inside. So what we'll do, d11 is R prime, and d1 to A2 is 0.25. The A2 again is R prime. A2 to A1 is also 0.25. So if we do that, then we take the power. So we can put it like the other time, Sumendran or who didn't understand, that we can write it like this: R prime times 0.25 to the power 1 over 2. So what's the value of this? Once you find the answer and tell me quickly. R prime is 0.7788 R. R prime is 0.7788 R. Tell me the answer quickly for this fellow. 0.0493. And anyone else? .0493. Anyone else? Two more of you should tell me the answers that you're getting. That's good donation. So how many we got? 1, 2, 3, 4. One more quickly. This is got the same, so 0.0493. Now we're going to do the same thing, self-mutual distance for capacitance calculation, because we have to do the capacitance calculation as well. So ds, and I'm putting C for capacitance. S is for self, is for capacitance. It will be the same, but the formula will have only R instead of R prime. So it will be R times 0.25, and its power will be still the same. So can you see how we can make it easy for us? If we calculated the DSL first, then we will have R prime in our equation, and when we want to go for DSC for the formula that will be required in capacitance to neutral calculation, we just don't use R prime, we use R. And we're getting an answer of 0.0559. Can you verify that if you are getting same answer? 0.559. Who else is getting the same answer? 0.559. Yeah, Dunge also got that one. And many of you, I see on the screen that you are writing 0.559 m, 0.0493 m. And can you see how I wrote that 0.0493 m and 0.0559 m? Can you see that? What is the difference between how you wrote that number and that unit and how I wrote it? Can you see that? Write down there. Can you see it? Can you find out the difference? How I wrote it? 0.0, yes. And none of you put any space. Only CISO-S1 there, 0.0493 m. That one I can see. Maybe up there someone else. Most of them are not putting the 8.82, no spacing, and only one from CISO was 0.0. So there, what you writing without space is wrong. Can't be without space. If you're saying this 0.0559 m immediately, it doesn't mean anything. It's neither 0.0559, it's nor 0.0559 meter, nothing actually. It's nothing. Meaningless. There is no such thing that people will recognize as like your those model numbers of your cell phones, S1, S7, unless or until someone knows what is S1 or S7 or S10, they wouldn't know what is that. You understand? So because we know that there is something called a cell phone S5, and we know that it's S5. But if you only say S and they're separated by 5, that is something defined. We don't know that. So when we have this, we can calculate the L and N. Quickly calculate these two values and tell me the answer. L and P values quickly. Quick. Anyone? I have two more bigger ones are coming. You have to give me the answer quickly. 1.03 10 to the power minus 6. Is that the correct answer? Is that the correct one? CJ got the same, thank you. And who else is getting the same? Pundi got the same, thank you. Now you tell me the CN value. CN value, you tell me the CN 1.03 times 10 to the power. Hello? No, that is wrong number, madam. No. Thanks. You tell me the CN value now quickly. N is 1.07 times 10 to the power minus 11. Who else is getting that value? Who else is getting that value of Cn, which is equal to 1.07, and then we have 0.9, which are very close. Anyone else? Anyone else quickly? 1.098 is also close. So you should have this value. So can I go to the next one, which is having 4 subconductors in the transmission line? It's the same configuration, same thing, horizontal configuration, 3-phase transmission line, but this one has 4 subconductors. This one has 4 subconductors for each phase. For phase A, we have 4 subconductors. For phase B, we have 4 subconductors. For phase C, 4 subconductors. They are arranged in the formation of a square, but they are still sitting on the circle, periphery of a circle. And the diameter of each conductor is given in this case is 50 millimeter. Diameter of each conductor is given 50 millimeter. And the spacing between the subconductors is given 0.5 meter, and the distance between phase A and B is 30 meter. Also, the distance between phase B and C is 30 meter. The distance between C and A we will calculate. So it's the same thing. What we will have to do, we have to do the DM, which is mutual EMT, which is easy. We did it. So what it is, the AB times the BC times the CA, and we take corresponding root, which is 1/3, because we have 3 terms inside the circular bracket, and then we put the distances. What we have 30 for DAB, we have 30 for DBC, and we have 60 for the CA, 30 for 30, and then we take the corresponding root, and then we should have the value of this VM. Quickly tell me the answer. 37.798. Answer from Sahil. We should get it verified from others quickly. It's a very easy one. Mission also got thank you. Who else have it? 2 more quickly, at least 2 more of you. Dunga got the same. And don't just say the same because I'm asking you or forcing you or making you to do it yourself using your calculator, so that you learn now. The main aim, what I'm trying here in this type of practice, is that we learn it here so that we don't have to worry, or don't have to even, actually, if you learn it here now, you don't have to prepare for your test at all. You will know it from here, because you're writing your test on Monday, which is just after 3-4 days from today. So the 37.798. Now we can go for calculation of BSL. So B is for self and L for inductance. So self D go all the distances. So conductor 1, the distance of 1, 1, 4. So for conductor 1, there will be 4 distances involved. Now when you are done with conductor 1, we'll go to the conductor 2. So 2, 2, 2, 3, 2, 4, 2, 1. So another 4 set of distances. When you're done with 2, we'll come to conductor on distance 3, 3, 3, 2, 4, 3 to 1, 3 to 2. So another 4 set of distance. So when we're done with 3, we go to conductor 4. So 4, 4, 4, 1, 4, 2, 4, 3. Now we're done. So we can start with one conductor and then we'll go to the next one, next one, next one. Is that clear? Let me know. Yeah. So thank you. So if we do that, we'll have 16 distances, but actually we can minimize it into 4 distances, because whatever distances we are getting from one of these conductors, any of these conductors, 1, 2, 3, or 4, will be the same for the others. Do you understand? Whatever distances we get from any of these conductors, let us consider that I'm considering conductor 1. Then I have 4 distances. It's on 1, 1, 1 to 2, 1 to 3, and 1 to 4. If I consider conductor 2, I will get the same distances. 2, 2, which is equal to 1, 1. 2 to 3, which is equal to 1 and 2. 2 to 4, which was equal to 1 and 3. 2 to 1, which was again is the same. So we can consider only one conductor and do the calculation easily, minimizing a lot of calculation. So what we'll do, D11, the first one, we'll take only one. So D11, and then D1 to 2, then D1 to 3, and then D1 to 4, and then we are done. Because all other distance will be the same, we don't need to just unnecessarily complicate the equation and make it very long. We can minimize our calculation, but still getting the correct answer. So you can put those values and tell me the DSL. Now D11 is what? R prime. D12 is what? How are you? Okay. D12 is what? D12 is 0.5, and then D13 is what? 0.5 squared and 0.5 squared. So 0.5 times square root 2. Sorry, let me put this bracket, square root of 2, because it's the diagonal, right? So that's the 1 and 3, and 1 and 4 again is going to be equal to 0.5. So I'm missing one. D11 is R prime, D12 is 0.5, D13 is 0.5 squared, 0.5 squared, that one, and then 1, that's fine. So now we put the power, so you can find out the value of this and tell me. Can you see how we simplified the equation? Instead of writing 16 distances and taking 16th root, we just used one because they are all identical. Then what's the value of this one? I missed that first bracket here. Sorry about that. What will be the answer? .724. Can you check it? Anyone else? .2422. That's the right one. 0.2422. Sibusisa got it. Zakari got it. Mukundi got it. Who did not get 0.2422? Who did not get 0.2422? What I should explain again, the distances, why I am not taking 16 distances. I am taking only 2. Sorry, only 4. D13 is the diagonal. D13 is the diagonal only. You can see it's a square. You know D12, you know D23. So you have to find out it's a diagonal, it's a square formation. All those 4 conductors, 1, 2, 3, 4, they are in the corners of a square, which is also all the conductors are also on the periphery of a circle. So it's 1, 3 is the diagonal. So 0.5 squared plus 0.5 squared. If you do that, so it becomes 0.5 times square root 2. D11 is our time. The distance between each one is D11. You see, we're taking conductor 1 only in this case. We're ignoring all other 3 because they are the same. We take 16 distances. On these 4 subconductors, we will have 16 distances, which are same for each of those single subconductors. We don't need to worry about that. So if we take only 1, so first conductor is 1, so we take D11. First and second, the distance between them is D12. That's what we wrote there. So then the next conductor is 3, so D13, and the next conductor is D1. So that's what we wrote there. And then coming to each of these distances, looking at D11 is what? D11 is nothing but R prime. D12 is given there, which is 0.5. That's what I wrote there. D13 is the diagonal, which is 0.5 times square root 2. You do it from grade 3. And then D14, which is 0.5 again, because this square formation. And then we took the corresponding root, which will be giving 0.2422. So we can find out the DSC now quickly. For DSC, it will be R times all those things. We will not have R times. So we will have only R in that equation of DSL. It will be R, and then you find out the DSC. In the equation of DSL, you just use R instead of R prime, you will find DSC, and you tell me what is the value of DSC. And 257 from Mukundi. Who else have the same value? Who has the same value, like 0.4257? Gusiso has the same. Who else is having the same value of 0.257? Two more of you should tell me that you got the same. Lubo got the same. Thank you. Who else is having the same? one more quickly. But it's 0.258. Yeah. Okay. Thank you very much. Sahil also got the same thing. So now you can calculate the L and C. Yeah. We don't need to worry about that. You can calculate the L and C yourself. Can I go to the next one? Can I go to the next one? Because you can calculate L and C yourself. L value is what? And Cn is what? You can do that yourself. It's not a that is different from the previous ones. It's the same formula, dm over dsl and dm over dsc for capacitance calculation. The formula and everything remains same. So let me go to the next one, in which you can see we have 8 subconductors in a phase for a 3-phase transmission line. 8 subconductors for one phase. Phase A. Phase A is here, phase B is here, phase C is here. Each of these phases having 8 conductors. Conductor 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8 for phase B. 1, 2, 3, 4, 5, 6, 7, 8 for phase C as well. And all the conductors are always sitting, no matter how many subconductors we are using, 2, 3, 4, 5, 6, 7, 8. Those conductors, I didn't show it in the other diagram, but all of them are always sitting on the periphery of a circle. So in this case, it's the same. I drew it and then I show you that they are sitting on the periphery of a circle. The radius of that circle is 1 meter and diameter of each conductor is 50 millimeter. Each of them having a diameter of 50 millimeter. And then the distances between the phases are given here. Between A and B is 80, B and C is also 80, C and A will be 80 plus 80, 160. So we'll have to do the same. So let us start with the DM, which is the easiest one. So DM is mutual GMD, and we do it how? We write it BAB times the BC times the A, and then we take the corresponding root, which is 3 terms we have in the bracket for the 3 distances AB, DC, and CA. Then we put those distances, and then the distances are 80. What is happening? 80 times 80 times 160, and then we take the cube root, and that should be equal to what you should tell me. $100.79. Is anyone else getting the same answer? 100.79. Anyone else getting the answer quickly? Two more of you should. Dunga got that 100.794. That's perfect. Thank you. Who else is having the same answer? Yusisha got it. So that's the DM. Now the next step is to calculate DSL. And this DSL calculation will be a bit longer one, because we have so many conductors, 8 subconductors in each of them, but we don't need to consider 8 of them. If you remember, in the previous one we have had 4, but we did not consider all 4, we consider only 1. The same thing we will do here. We will consider only 1, but we'll have 8 distances here. We have had 4 subconductors, we have had 4 distances. In this case, we have 8 subconductors, we still consider 1 of them, we will have 8 distances. So we are going for self DSL, self GMD. We are considering conductor 1. So what we have, the first one, so D11, that's the first distance, conductor 1. So the next one is D12, the next one is D13, D13, the next one is D14, D15, D16, D17, D18. That's all distances between conductor 1 and others in that self group. And then we have to take the corresponding root. How many of them are there? 8 of them are there. D11, 12, 13, 14, 15, 16, 17, 18. Is that clear to everyone? Is that clear to everyone? Anyone else can confirm that they understand this? All the 8 distances of the subconductor number 1, we considering only one conductor 1. So its own distance 1, 1, 1 to 2, 1 to 3, 1 to 4, 1 to 5, 1 to 6, 1 to 7, 1 to 8. We reach the last conductor. Now we need to know what is D11, what is D12, and so on. Right? So D11 is what? We're going to write here. D11 is actually R prime. That's its own distance. D12 is what? We need to find out from the geometry. Now, when we have 8 subconductors, what's the angle here? If we, let me try to draw a line. If I try to draw a line, what is happening? What is wrong with this one? Oh, okay. So if I try to draw a line here, find out the angle. What's the angle of that one? Tell me. I can write the distances here once again. DSL. What's the angle here? Anyone can tell me? DSL is equal to D11 times D12 times D13 times D14 times D15 times D16 times D17 times D18. What's the angle that one? 45 degrees. Now we need the distance D12. Can you see? D11 is R prime. We said that one. That one is easy. If we know R, which is given from the diameter, we can find out R, which is okay. But for finding D12, what we need to do? We need to draw a line from here to there, and then draw this perpendicular from there. And that theta will be now half of that 45 degree, and then we know this one is 1 meter. Is the RC, the radius of that circle is given. And this is RC, and this one is, this angle is theta. So we can find out half of this distance between 1 and 2 from there, and then we can write actually D12 will be 2 times RC times sine. How are you? Okay. Okay. Good. Yeah. You came today. Oh, okay. 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 Thank you. So we having RC sine theta, and theta is 22.5 times not x, that's times sine theta. We can find out that. So for the next one, D13 will be 2RC sine 2 theta, 2RC times sine 2 theta, 2 times 22, sorry, 2 times 22.5. Can you understand that? Or it's equal to 2 RC times sine p theta p times 22.5 d15, and find out d15, 2 RC times sine 4 theta d16 equal to 2 RC sine 5 theta, and then d17 will be 6 theta, d18 is 2 times RC times sine 6 theta. D18 actually is equal to D12. You don't need to calculate. If you want, you still can use the same formula. 2RC times sine 7 theta, they will become the same 22.5. So you can calculate all the distances, right? And when we have all these, you can put that in the equation of DSL, in that big equation, D11, 12, 13, 145, 16, 17, 18, all the distances there. And can you calculate that value and tell me, anyone? I'll continue it tomorrow, but I just want this DSL value now. What is the final value of DSL? Because it's 8:30, so within 2-3 minutes we can do this calculation of DSL. What is the value of DSL? RC is equal to 1 meter, that is given there. Anyone who can calculate the DSL value, putting all the values of D11, D12, 13 through D18 into the equation of DSL and taking corresponding root. I forgot to put that root 1/8 in that equation when I rewrote it second time. The first time it was there. The corresponding root should be 1/8, 1/8.